Hi, my name is Irving, and this is my conclusion of the first evidence of the Model 1. And during the development of this evidence, we were able to exemplify what we saw from the topic 5. And as a team leader, again, I had the task of giving each of the activities and the step by step of the evidence and looking for an efficient way to carry it out. An example of this was that we we couldn't bring a bicycle so easily to the campus, so I looked for a way to adapt this. And once the video was recorded, it became clearer that the way the sound travels will change depending of the temperature, distance, frequency with which it is emitted.
Sofía Molina Padilla. I think this evidence was a little more complicated because we need to use objects, not just information provided by the problem. I liked it because at the same time we were able to understand more the concepts of waves and how they work depending on where the sound comes from. It also helped us to better understand the concepts of different types of waves and their difference, as in the transverse and longitudinal, this within the anatomy of the waves and their four parts. I found this model interesting because although it seemed complicated, with the exercise and examples it was easier to understand.
Hi, my name is Linda Sofia Martinez Jimenez, and what I learned from this experiment was that we can calculate the frequency of some sounds, and with this frequency, we can also calculate like the intensity of the sound, so we can know if the sound can be dangerous or not for us.
Hi, so my personal conclusion is that when we talk about sound, we refer to the programmation of mechanical waves caused by the vibration of a body through a fluid or an elastic medium. These waves may or may not be perceived by living beings depending on their frequency. Sound is produced when a body vibrates and transmits these vibrations to the surrounding medium in the form of sound waves. They travel expansively at an average speed in the air of 343 meters per second and can bounce off different types of sources, achieving different echo or distortion effects which often magnify their power. This experiment let us see these things, these kind of frequencies, and all that involve the sound. And I think it's really interesting how these little variables can change with the sound and how you perceive it in a distance, in a determinate distance. Thank you.
My name is Luis Eduardo Martinez Ramirez. I'm from the group number 602, and my conclusion about the evidence number 1 is that it seems really interesting to know about the frequencies because it's a really common thing in the world, like when a car moves close to you. I didn't realize you could calculate the frequency of its sounds or the length of the waves when it comes to measure something about the sound. And I really like these topics because it's something really interesting for me.
Hi, I'm Max Salazar, and what I learned from this evidence was is like how easy is nowadays to calculate the frequency of many sources. Like for example, a car that is passing away from us or that is moving to us, and how easy can we calculate that, and how can we do that, like with the formulas that we learned and that things. I think that is very important because with that we can take care of ourselves of the dangers that the sound can make. Because we, as you know, we have the ears, and with that we can hear everything that is around us. And without that, it will be very difficult to keep the life that we get. It's not like a very bad thing, but I think we need that in our lives.